Hello everyone, welcome back to our Python programming fundamental series. I hope you have been practicing these concepts from our previous lectures because today's lecture builds directly on them. As always, before learning something new, let's spend a few minutes revising what we have learned in the previous lecture. The programming is a practical skill, and regular revision helps us connect new concepts with ones we have already learned. So in the previous lecture, we focused on the advanced functions where we started understanding variable scope. There we have learned that every variable has a specific area where it can be accessed. Some variables are available only inside a function, while others are available throughout the program. Then we have studied local variables. These variables are created inside a function, can be used only inside that function, and disappear once the function finishes execution. Because of this, trying to use a local variable outside its function results in a name error. After that, we have learned about global variables. Unlike local variables, global variables are created outside all functions. They can be accessed from different functions, and if we want to modify them inside a function, we can use global keyword. And we also discussed about professional programmers try to avoid excessive use of global variables because they can make large programs harder to maintain. Next, we explored different ways of passing arguments to functions. We started with default argument. These allow us to assign predefined values to parameters. If we don't pass an argument, the Python automatically uses the different value. If we provide a value, Python replaces the default with a new value. Then we have studied positional arguments. Here, the order of arguments are extremely important. The first argument goes to the first parameter, the second argument goes to the second one, and changing the order can produce incorrect results. To overcome this limitation, we have learned keyword arguments. So instead of depending on positions, the Python matches arguments using the parameter names. Because of this, the order no longer matters, making the programs easy to read and less prone to mistakes. Then we have moved to variable length arguments, where we'll be using star args. We learned that asterisk args allow a function to accept any number of arguments. Python collects all those values into a tuple, making the function much more flexible. Finally, we learned about lambda functions, also called anonymous functions. These are short, one-line functions created using the lambda keyword. We also saw how lambda functions are commonly used with filter, map, and reduce functions to process collection of data efficiently. Now that we have built a strong understanding of functions, today we will move one step further. So according to this PPT, today's concepts are function composition, Python modules, import statements, and some built-in modules where I will be discussing about math module and importing specific functions, module allies, Python math module, and then numerical functions, recursion, and recursive programs. By the end of today's lecture, you will understand how professional programmers organize large projects, reuse codes from different files, and perform advanced mathematical calculations, and solving programs using one of the most fascinating concepts called recursion. So, without wasting any more time, let's begin with our first topic called function composition. Now, let's begin with today's first concept, which is function composition. The name may sound a little technical, but the idea is actually very simple. We have already learned how to create functions. We have learned how to call functions. Now, we are going to learn how one functions can work together with another one. This is called function composition. So what exactly is function composition? Let's understand the definition first. Function composition means combining two or more functions to solve a problem. Instead of writing a huge function, we divide the work into smaller functions. Then the output of one function becomes the input of another one. That's exactly how the PPT defines it. So why exactly do we need it? Imagine your morning routine. Do you do everything at the same time? No. First, you wake up. Then, you brush your teeth. After that, you take a bath. Then, you get dressed. Finally, you leave for college. Each step depends on the previous one. Together, they complete your morning routine. So, like that, function composition works exactly in the same way. Small functions working together to complete a larger task. So let's have a simple example. Suppose we want to perform two tasks. First, multiply number by 2, then add 5 to the result. Instead of writing everything in one function, let's divide the work. Like, let me open the program. Def multiply by 2, then I'll be getting number as the parameter and return number multiplied by 2. And the next function will be def add the score 5 of number and then return number plus 5. So both functions perform exactly one task. Now let's use them together. So let's have result equal to add underscore 5 and then multiply by 2. After that, I'm having tens as an argument. So if I print result, the output results in 25. So let's understand what happened here. So the innermost function, so multiplied by 2 of 10 returns 20. So according to this, number multiplied by 2 is 10 multiplied by 2, which is 20. So that value becomes the input for add 5. So add 20. So this returns 20 plus 5, which is 25. That's exactly what function means. One function finishes its work and its output becomes the input for another function. So understanding using mathematics. Okay. So this PPT also mentions that in mathematics, function compositions can be written as f of g of x. Here, g of x executes first and its output is passed to f of x. Let's understand this. Suppose g of x is equal to x multiplied by 2 and f of x is equal to x plus 5. Now f of g of x, the f of g of 10. The step 1 will be g of 10 which output is 20. Then step 2, pass 20 into f of x, so the output will be 25. Notice something. The inner function always runs first. This is the same thing what Python does. So let's have another practical example. Let's imagine we are creating a student marks program. First, we will calculate the total marks using def total m1, m2, m3. 1 minute. Yep. And we'll be returning m1 plus m2 plus m3. So the next we will be calculating the percentage of that. So percentage total underscore marks. So here we will be returning total marks by 3. Now instead of writing two separate statements, we compose them by result equal to percentage of total of 80 comma 90 comma 85. So, and then after that I'll be displaying using print result. And if I save it and run, it gives the result 85.0. So let's understand the flow. So first the Python executes total of 80 plus 90 plus 85, which is 225. Then this 225 gets passed to the percentage. So here 225 becomes the input. So percentage of 225. So 225 divided by 255 divided by 3 gives 85.0. So this makes the program much cleaner. So let's see the exact benefits of using function comparisons. So these were the examples which we have saw. So the basics of function, the benefits of function comparisons are, the first one is modularity. So instead of writing one huge problem, we divide the problem into smaller functions. Each function has only one responsibility. So this makes programs easier to develop, test, and debug. So suppose our percentage function is needed in another program. Since it's independent, we can reuse it. So without writing the logic, this saves both time and effort. So better readability. Look at this line. Let me open this. So look at this line. So result equal to percentage total of this thing. So without even reading the function definitions, we immediately understand the function is doing its exactly the function is doing. First it's doing from the total one, and then the total value is passed to the percentage, and finally we are returning the percentage value. So this is an advantage of meaningful functions. They make programs easy to read. So also this avoids side effects. Like, this simply means each function does something on its own without necessarily changing other variables or other functions. So as a result, Python becomes more predictable and easy to maintain. But there is one small limitation in this function composition. Thus, that the function composition generally works best when each function accepts a single input. If a function requires multiple input, we may need tuples or other techniques to pass those values. For now, don't worry too much about this. As beginners, understanding the basic idea of passing one function's output into other function is enough. So let's test your understanding on function comparison. Consider I'm having def double of x. So what does this function do? It returns x multiplied by 2. And the next function is def square. Here it returns x multiplied by x. So now predict the output of print square of double of 5. If pause the video and think, first double of 5 returns 10, and next square of 10 returns 100. So the final output is 100. So let's see if I change the function type. Like, first I'm having double, and then inside that I'm having square. So double of square of 5. So will these two things have the same output? Let's see it. Okay. So the first one results in 100, whereas the second one returns 50. So this exactly why we need to have a proper adder for having function compositions. So let's summarize what you have discussed in this topic. So function composition means combining two or more functions. The output of one function become the input of another one. Let's help us write some smaller cleaner, and reusable programs. The main benefits are modularity, reusability, better readability, and then reduce side effects. These are exactly the reasons the professional programmers prefer breaking large problems into small, well organized functions. So, let's see some or more examples. Suppose we can also compose two functions. So that says f of g of x equal to f of g of x. So how we can exactly do it using function, let's have another one function called def compose where I'll be taking these two functions as the parameters. After that, using return lambda x, and the expression will be f of g of x. So this exactly does def add and then def multiply. So the f value will be multiplied and the g value will be add. So add of x. So x, what does it do? So add of 5. So 5 plus 2 will return 7, and this 7 is multiplied by 2. So that is 14. So compose this thing does this output. So I hope you understood what exactly it does. So consider this function where def process input x comma y, which returns x multiplied by 2 and y multiplied by 2. So this comparison typically expects each function to take a single input. However, if you are using functions to handle multiple arguments, you can adjust the comparison function to handle tuples or other structures. So this is exactly how we'll be doing this comparison. So I hope you have understood this topic. So now that we have learned how functions work together, let's move to the another important topic called Python modules, where we'll learn how programmers organize code into separate files and reuse it across multiple programs. Now, let's move to the another way of important concept called modules. So until now, all our programs were written inside a single Python file that works perfectly for small programs. But imagine writing a complete banking applications or an online shopping website. So do you understand? Everything can be written inside one file. Of course not, right? So real software projects may contain hundreds or maybe even thousands of Python files. That's where modules become useful. So what exactly is a module? Let's understand the definition first. A module is simply a Python file that contains codes such as functions, variables, and then classes which can be reused in another program. So instead of writing the same code again and again, we write it once, save it in a single file, and then import it. So whenever we need it, that's exactly what this PPT explains. So imagine your college library. The books are kept randomly. These are separate sections. So one section contains mathematics books and the another section contains computer science books. Another contains physics books. Whenever you need a particular subject, you simply go to that section and instead of searching the entire library, modules work the same way. So instead of placing all code inside one single file, we organize it so into different files. So based on the papers. So why do we need exactly these kind of modules? So the modules exactly help us organize codes, reuse codes, and make programs easier to manage. Let's understand why. So these modules help us to have a better organization. So instead of one huge file, we divide our program into small files and each file has a specific responsibility. This makes programs cleaner and easier to understand. So next one is code reusability. So whenever you have written a calculator module, tomorrow then you start another project, you want to rewrite all those functions. No, right? Simply you have to import that module and use it again. So imagine finding a mistake inside one function. So instead of searching throughout of hundreds of lines, you can simply open the appropriate module, correct the mistake, save it, and this makes the maintenance much easier. Now, how do we use a module? So Python provides a keyword called import. So the PPT states that import statement brings a module into our program, and let's see an example. Suppose we want to use math module. So what we can do is import math, and now our program can use all functions available inside math module. We will study the math module in detail later in this lecture. For now, remember one thing. Without import, Python does not know that we want to use another module. So there are some two types of modules called built-in module, where these are already included with Python and no installation is required. So examples include math, random, and OS. We already saw about random module, where we have imported random and made a guessing by number guessing software. So we simply import them and start using them. So next thing is external modules. These are not included with Python but must be installed. So before we use them, the some popular examples are pandas and numpy. These were widely used for data analysis, scientific computing, and machine learning. As beginners, we don't need to learn them now. We will encounter them later. So as you work on larger Python projects. So this PPT further explains that built-in modules can be imported directly using import keyword. So without any installations. For us, for example, import random or import math. These modules are already available because they come with Python itself. That's one of those reasons why Python is so powerful. Let's use many useful tools are already built in. So let's test your understanding. Suppose I want to use a file called math module. So which statement should we write first? We use import maths. Exactly. That that's all we need. And after importing, we can start using its functions. We will see practical examples very soon. So let's summarize what we have discussed in this lecture. A module is simply a Python file containing a reusable code, and modules help us organize programs, reuse functions, and manage large projects. To use a module, we write import and then module name of that module. Okay, so Python modules are mainly two types called built-in module and external modules. So built-in modules come with the Python, while external modules must be installed separately. So now that we have learned how to import an entire module, let's explore different ways of importing the parts we need. Including importing specific functions and module alias. Okay. Now, in the previous section, we learned how to import an entire module. For an example, import max give us access to everything inside the Python module. Now, but here is a question. What if we only need one or two functions? Do we still need to import the entire module? So here Python gives us a better option. So let's understand it. Importing specific functions. So imagine you visit a library and there you need only one book. Will you carry the entire bookshelf to your home? Of course not, right? You will take only one book. So like that, Python works the same way. So instead of importing the entire module, we can import only the required function. So the PPT explains that it's done using from keyword. So the general syntax is from module name import the function name. So let's take an example. from math import square root. So let's have it. So from module name import the function name. So instead of writing math.sqrt25, we directly use print sqrt25. So this returns the output 5.0. Notice something, we didn't have to write math dot before the function name because we already imported one leaf through a square keyword. So importing multiple functions. Suppose we need more than one function, for example square root and power. So we can write from math import sqrt comma POW. So POW stands for power. Now both the functions are available directly. So if I do sqrt of 64 and then next one is print POW 2 comma 5, and if I save it and run, it gives 8.0 and 32.0. So this helps our code clean and simple, easy to read. The PPT also mentions that another method we can import everything from a module using asterisk keyword, asterisk symbol. So example, from math import star. Now all functions inside the math module can be used directly. For an example, wait, from math import asterisk. So if you're using it, I can use the QRT 49 print POW 3 comma 4, and if I save it and run, it gives 7.0 and 81.0. So before here we don't need to write math dot before every function. So however, professional programmers generally avoid using math module from math input star because many functions have similar names and it becomes difficult to know which module they came from. So although Python allows it, it's usually to better import only a specific functions you actually need. Now, let's learn another one important method called modulus with alias. So let's learn this another useful feature. Suppose a module has a very long name. Typing it again and again becomes tiring. So Python allows us to give the module a shorter name. This shorter name is called an alias. So in this PPT, it explains the aliases are created using as keyword. So for an example, import math. So here we can also write import math at m. So now instead of math.sqrt, we can have m.sqrt and then 81. And then if I print, let me have it print. Notice this math module is aligned as m. So both the programs produce the same results. So if I have math.sqrt 81, it too gives, let me import max here, import math as m. And now if I have math.sqrt of 81, it says math is defined, not defined. But if I do m.sqrt of 81, it gives the output 9.0. So imagine you have a friend named Krishnamurthy, but every day you call him with this full name, it would take time. So instead, everyone calls him Chris. That's exactly what an alias is. Original name still exists, but we use a shortened name for convenience. Similarly, Python allows us to module names. So when should we use alias? So alias are very useful when working with long module name. In future, when you learn data science, you often use import pandas as PD and import numpy as NP. Almost every programmer uses these aliases. They have become an industry standard. So let's test under our understanding. Suppose we write import math as m. How do we calculate the square root of 100? The answer is print m dot sqrt of 100. So simple, right? And if I run it, it gives 10.0. So let's summarize what we have done in this topic. So instead of importing an entire module, we can also import only the required functions using from module import functions. We can also import multiple functions or even all functions using from module import asterisk. Finally, we have learned about module aliases. Using the as keyword, which makes the code shorter, cleaner, and easy to read. Now that we know how to import modules, let's explore one of the most useful built-in libraries called. Now, let's explore one of the most useful built-in modules available in Python, the math module. So, almost every programming language provides a library for mathematical calculations, and Python is no exception for this. So instead of writing complex mathematical formulas ourselves, Python already provides ready-made functions that are accurate, fast, and easy to use. So what is a math module? So the PPT defines that math module as a built-in library containing mathematical functions and constants. This means it already comes with Python. So there is no need to install anything. We can simply import it. So and start using it. The first step is import math. So once we import it, we can use many mathematical functions provided by Python. So why do we need math module? So the PPT lists several reasons. Let's understand them. So complex mathematical operations. Suppose you want to calculate square root of a number. So instead of writing your own algorithms, Python provides already provides a function called math. Math.square root. So this gives output 8.0. Simple, right? So the second one is mathematical constants. So the Python module also provides important mathematical constants. For an example, math.py. When we need to have a value of pi, we simply use math.py to get the value of pi. Similarly, Python also provides Euler number using math.e. So these constants are widely used in mathematics. So these constants are widely used in mathematics, physics, and engineering. So the next thing is better accuracy. Suppose you calculate very large powers, logarithms, and trigonometric values. Doing everything manually can introduce errors. So that's why Math Module gives high accuracy and optimized functions. So that's why professional programmers prefer built-in libraries. So instead of creating their own mathematical functions. So real-world applications. So this PPT also mentions that the math module is useful in physics, statistics, geometry, finance, and many engineering applications. Whether you are developing a scientific calculator or a banking system, yes, or a simulation, the math module becomes extremely useful. So looking at the few common used functions like let's import math and print math.sqrt of 81. and this gives output 9.0 and similarly power. So math dot POW 2 comma 5. This results in 2 to the power of 5, which is 332.0. Notice power rises only one number to the power and the another number. Sometimes we all simply need a positive value of a number. So for that we use ABS minus 25. So, so this results in 25. So the PPT specially highlights two numerical functions like seal and floor. These functions are very useful when working with decimal numbers. The seal function, the word seal means ceiling. Imagine you are standing in a room, the ceiling always above you. Similarly, the seal function always rounds the decimal upwards to the nearest integer. Example. So let's have an example here. Suppose I need to print seal of 4.2 and this results in 5. Let's have another example. Math dot seal of 7.0001. So no matter how small the decimal part is, the seal always moves upward. So now let's look at the opposite. The floor gives us the floor function always rounds the decimal number downwards to the nearest integer. Let's have an example here. So let's have print math dot floor 4.99999. So if I print it, it gives 4. So let's have another example. Math dot floor minus 3.000001. If I print, it prints minus 4. So unlike seal, the floor function always moves downward. So remember this trick. Think of yourself standing in a room, look up to see the ceiling, so seal goes up. Look down, you see the floor, so floor goes down. The similar visualization may help beginners remember the difference. Let's check your understanding. So what if I print math.seal 5.1? It returns 6. And what if I print math.floor 5.9? It prints 5 because seal moves upward while floor moves downward. So let's summarize the math module. This math module is a built-in Python library containing mathematical functions and constants. We learned why it is used, how to improve it, and how to use functions like square root, power, seal, and floor. We also learned about mathematical constants like pi and e. These functions are widely used in scientific and engineering, financial, and real-world applications. Now, it's time to learn one of the most interesting concepts in programming, recursion, while where a function can actually call itself. This may sound surprising, but by the end of this section, you will exactly know how it actually works. Now, let's move to one of the most interesting and at the same time one of the most challenging concepts in the Python programming, which is recursion. So when beginners hear about recursion for the first time, they usually get confused. But don't worry, we will understand with simple examples, real life analogies, and then we will write our first recursive program. But by the end of this lecture, you will understand why the recursion exists and how it actually works. So what exactly is recursion? So let's begin with the definition. So according to the PPT, recursion is a process in which a function calls itself until a stopping condition is met. At first, this sounds strange. So a function calling itself. Yes, that's exactly what a recursion is. So instead of another function calling it, the function calls itself and keeps calling itself again and again until a condition tells to stop it. Why do we need recursion? Now, you might ask, if loops already exist, why do we need recursion? That's a very good question. Some problems are naturally repetitive. So instead of writing long loops or complicated logics, we can solve them by breaking one large problem into a smaller versions of same problem. Recursion allows you to think in terms of solve one small step, then learn the function, solve the remaining steps. This often makes certain programs cleaner and easier to understand. So imagine you stand between two mirrors facing each other. What do you see? Your reflection inside another reflection and inside another reflection. So again and again. It looks like it is a continuous forever, but actually it doesn't. Eventually, the reflection becomes too small to notice. The recursion is similar. A function calls itself. When that's a new function calling itself, and the process continues until a Python reaches a condition that tells it stop here. So, have you ever seen Russian nesting dolls, and also called Matryoshka dolls? You open one biggest doll, inside that there is another one doll, and you open that one, another doll, again another one. This continues until you reach the smallest one. That smallest one cannot be opened further. This tells you this is the end, and this smallest doll is like the base case in the recursion. So think about a countdown. It starts from 5, then 4, then 3, then 2, then 1, and then stop. Notice something. Every number does the same job. It simply says print me, then continues with one less eventually. We reach 1. After that, the countdown stops. That's exactly how the recursion works. So, suppose your teacher asks count from 10 down to 1. Do you solve the whole problem at once? No, you say, I will first print 10. Then I will solve the remaining problem, which is 9 to 1. So when you reach 9, you say again, I will print 9, then solve 8 to 1. And every step, it handles one small task and leaves the remaining work to the next call. This is the basic thinking behind this recursion. So every recursive function has two important parts. This PPT emphasizes that recursion must include a stopping condition called the base case. Let's understand the both parts. So the base case is the condition that stops the recursive calls. It tells Python don't call the function anymore. Without the base case, the function would continue forever. So the second one is recursive case. It is the part where the function calls itself. This is what makes the process continue until the base case is reached. So every recursive function always has these two parts called a base case and a recursive case. Remember them, they are the heart of recursion. So what makes without a base case? Let's imagine a function that calls itself without any stopping condition. That would happen. What would happen? It would call itself again and again and again forever. Eventually, Python runs out of memory for storing all these function calls. When that happens, the program stops with an error called a recursion error or a stack overflow. Don't worry about the technical details now. Just remember one simple idea. If a recursion function never stops, the Python cannot continue forever. Eventually, it runs out of space to remember all those function calls. That's why every recursion function must have a base case. So let's see the general structure for the recursion. So here I have described def, function name, then value, and there will be one base condition or stopping condition, and then the return the base value. Then in that else we'll be having return the function name the smaller problem. This thing is notice something inside a function we are calling the same function again. And what makes it recursive? Before before that, we always check that stopping condition. If the stopping condition is true, the function ends. Otherwise, it calls itself again. This simple structure is followed by the almost every recursive program. So right now, let's summarize what you have done in this recursion. So recursion makes a function calls itself. It solves a large problem by breaking into smaller problems. Every function has two parts, namely base case and recursive case. The base case stops recursion. Without the base case, the recursion continues indefinitely and eventually casts a recursion error because Python runs out of space for additional function calls. Now that we have understand the idea behind recursion, now it's time to write our first recursive programs where we will see step by step how Python calls the same function repeatedly and how the calls are completed and how the answers return back to the original function call. Now let's write our first recursive program. We will use the most famous example called the factorial example. So before writing that program, that is factorial, let's understand the problem first. Suppose I ask you what is 5 factorial. So what is it? That is 5 multiplied by 4, then multiplied by 3, then 2, then 1, which is 120. Similarly, 4 factorial is, 4 factorial is 4 multiplied by 3, then 2, then 1, which is 24. The 3 factorial is 3 multiplied by 2, then multiplied 1, which is 6. So the 2 factorial is, 2 multiplied by 1. Finally, 1 factorial is simply 1. So now look carefully in this and don't look at the answer. Look at the pattern. 5 can be written as 5 into 4 factorial and 4 can be written as 4 into 3 factorial and 3 can be written as 3 multiplied by 2 factorial and 2 factorial can be written as 2 into 1 factorial. So did you notice something? Every factorial depends on the another factorial and only the number becomes far smaller. That's exactly the idea behind recursion. So now let's think like a programmer. Someone asks what is 5 factorial? Do I need to calculate everything myself? No, I simply say I know 5 factorial is 5 multiplied by 4 factorial and that's it. Now finding 4 factorial becomes someone else's job. Again, 4 factorial says I know I am 4 multiplied by 3 factorial. Again, 3 factorial says I am 3 multiplied by 2 factorial. And then at last, 2 factorial says that I am 2 multiplied by 1 factorial. Finally, 1 factorial says I know my answer. I am 1. So did you see what happened? Nobody tried to solve the whole problem. Everyone solved only one small part. And that's exactly how recursion works. So now let's convert this thinking into code. First, let's create a function called def fact of n. So very simple. The parameter n represents the number whose factorial we want to find. Now we write the base case. If n equal to 1, then return 1. Because we already know 1 factorial is always 1. There is nothing more to calculate and that's our stopping point. Remember, every recursive function must have a base case. Without it, the function never stops. Now comes the most important line of the entire program, that is return n multiplied by fact of n minus 1. So don't rush. Let's understand every word. Python is saying, I am going to calculate the whole factorial right now. I will multiply the current number with the factorial and one of the smaller numbers, that's all. And this line creates the recursion. Now, our program looks like this. Print fact of 5. So look small, only a few lines. But behind all these lines, Python prefers many function calls. And let's see what actually happened. Suppose we execute fact of 5. So the n value will be Python immediately calculate the answer? No, because it first needs the value of fact 4. So the Python says I will come back later. So 5 multiplied by fact of 4 is called and the 4 is done. 4 multiplied by it says first and the first iteration says 5 multiplied by, let's keep it here what it's happened. First call 5 multiplied by fact of 4. Then 4 multiplied by fact of 3. Then 3 multiplied by fact of 2. So later 2 multiplied by fact of 1. So this is what happening here. And now the Python reaches fact of 1 and that's different because this is our base case. So the Python knows the answer simply returns 1. So this becomes 1. So 2 multiplied 1, 1 will be the fact of 2, which is 2. So 3 multiplied by 2 will be simply 6. So fact of 3 will be 6. Then 4 multiplied by 6 will be fact of 4, which will be 24. So 5 multiplied by 24 is nothing but it's 120. So now we get the required answer which is 120 and that's it, it will be the final output. So I hope you have understood the biggest idea of recursion. So let's see the output whether it's correct. See, it's correct. So let me have a different factorial. If I have fact 10, it says the different one. If I say fact 6, it gives 120 into 6, which is 720. Fact 7 will be 720 into 7, which is 5040. So it goes on like that. So the biggest idea of recursion is, remember this, while you go down, Python does not calculate anything. It simply keeps creating smaller and smaller problems. And only after reaching the base case, Python starts coming back. And while coming back, it completes all the pending calculations one by one. And if you understand this one idea, you have understood the most difficult part of recursion. And I hope you have understood this part. And then let's have a sample, another one example. Let's have another simple recursive function that counts down to the 5. So def countdown of n. So here, if n less than or equal to 0, it prints done. Else, it prints n and countdown n comma 1, n minus 1. So if I give countdown of 5, so Python returns 5, 4, 3, 2, 1, done. So I hope you have understood this thing. So how exactly this thing happened, which is the 5 countdown 5 is passed here. So the initially n value is 5. So it checks whether the condition 5 is less than or equal to 0. But this thing is false. So the else part is worked here. So print n and then again call count down n minus 1. So now the n value is 4. Now it prints 4, and after that the function is called again with n minus 1. Now the n value is 3, so it prints 3. Then 2, at last 1. After that n value becomes 0. So if n equal to 0, print done. So the done is printed here. So note, I hope you have understood this simple program. Now we know how recursion works, but where it is actually used. So why do programmers use these recursions? So when loops are already exist. So let's understand it clearly. So first advantage is cleaner code. So this makes the program much shorter. So let's within a loop based solutions. So instead of writing many variables or nested loops or and complicated logics, we can simply let a function call itself. The problem is become smaller and easier to read. Advantage 2 is easy problem solving, and which is 1 minute, give me a minute. So advantage 2 is easy problem solving. Recursion helps us to break one big problem into small problems. Instead of worrying about the entire task, we only solve a small step, and the recursive call takes care of the remaining work. This makes many difficult programs feel much simpler. Advantage 3. Natural for some problems. Some problems are naturally recursive. For example, refined family trees, folders inside folders, binary trees, divide and conquer algorithms, and trying to solve these problems without recursion often makes the code longer and harder to understand. Now, let's see the limitations of recursion. Now, does that no, recursion is always the best choice? No, like every concept, it also has some disadvantages. Limitation 1, more memory. So every time the recursion calls itself, Python has to remember that the function call, if there are many function recursive calls, more memory is required. So compared to loops, recursion usually consumes more memory. So the limitation 2 is slower execution. So because Python creates many function calls, recursion may be also slightly slower than the equivalent loop. For every large problem, this difference can be more noticeable. Now the biggest mistakes beginners make is forgetting the base case. Without it, the function never stops. Eventually, Python produces a recursion error. So always remember this one simple rule. Every recursion function must have a base case. So where is recursion used? Now you may ask, where will I actually use recursion? So the answer is more places than you might have expected. So folders inside folders. Open a file explorer, you will have one folder. Inside another folder. Inside that another folder. So computer uses recursive ideas to navigate due to the nested folders. Google Drive. Same thing happens in the Google Drive. Folder can contain another folder. That folder can contain another folder within itself. So the recursion is a natural way to process these kind of structures. Data structures. Later, when you study data structures, you will see recursion almost everywhere. For an example, binary trees, tree traversals, depth first search, merge sort, quick sort, and many other algorithms. So, don't think today's lesson is only for Python recursion. This is the important concept for throughout computer science. So, if your goal is software development or competitive programming or placement interviews, recursion is a topic you cannot avoid. Almost every company asks questions based on recursion or concepts built using recursion. So understanding it now will help you later stages. So before ending, let's quickly revise question number 1. What is recursion? A recursion calling itself is called recursion. Next, what stops recursion? Its base case. Then what happens if there are no base case? Correct. The function calling itself and eventually Python writes a recursive. Fourth question. Name one real world applications for recursion. Correct. They are like folders, trees, merge sort, quick sort, or binary search. So before having our recursion summary, let's quickly see what kind of recursions are there. So recursion can be broadly classified into two types. They are tail recursion and non-tail recursion. The main difference between them is related to what happens after recursive call. Tail recursion. The recursive call is the last thing that function does. So nothing happens after it returns. Some languages can optimize it to the work like a loop, saving memory. So non-tailed recursion function does more work after the recursive call returns. So it can't be optimized into a loop. So these are some two examples for recursive and non I mean tail factorial and non-tail factorial. And here non-tail factorial cannot be converted into a loop as this does many things rather having a separate factorial. Here this one is a tail factorial. So I hope you have understood the two types of recursion which are there in Python. So now let's quickly summarize what you have learned here. So we learned today, we started with the function composition. We learned how one function can use the output of another function. After that, we understood that modules are what modules are and why programmers split large problems into multiple files. Then we learned different ways to import modules, including importing specific functions and using module aliases. Next, we explored the math module and learned how Python provides ready-made mathematical functions like square root, power, ceil, and floor. Finally, we spent the largest part of today's lecture in understanding recursion, where we learned what recursion is, why every recursive function needs a base case, and how recursive calls work, how Python returns back after reaching a recursive case, and where recursion is used in the real world programming. So, congrats! You have successfully completed another important lecture in the Python programming series. So in this today's lecture, we have introduced concepts that you will continue using toward your programming journey. If recursion feels difficult, don't worry, almost every programmer finds recursive continuing. First time, the secret is practice. So write programs yourself, change the input values, perform dry runs using pen and paper, and more you practice, the easier the recursion becomes. So in our next lecture, we will continue explore Python with practical programs and new programming concepts. Until then, keep learning, keep practicing, and more importantly, enjoy the process of coding. So thank you for watching this lecture and have a wonderful day, and I will see you on the next one.